Hi, welcome to my series on distributed systems. In this series, we're going to learn about the fundamentals of distributed systems, databases, and how they work together. You and I are going to go through this series, and it's going to be a learning experience together. So let's get into it. Distributed systems is computer systems that is deployed into many machines. And we'll go into why it deploys to many machines. But some example of a modern day distributed systems would be Amazon, Google, right? All of these uh, large services are running on multiple computers, right? Uber, another example of a highly distributed service. Netflix, TikTok, all of these. So how do we evolve from, you know, how do we evolve to distributed systems, and why do we need distributed systems? Traditionally, applications are split into kind of a three-tier model. So, to draw this, there are three tiers. One, request handling, also called request routing, RR. And then we have the business logic, which does the computing. And then we have the storage, which is the database. In the early 2000s, Amazon was written as a single monolithic service. So this is a monolithic pattern where everything is deployed on pretty much one machine. And when user sends a request, this request lands on that one machine. Now you can imagine that this machine has some hardware limitations. It could either be CPU, hard drive, or RAM. Typically, when we have distributed systems, they are very data intensive, and it is bounded by these three parameters. And if you're running a large service on one machine, to scale out these parameters, you would need to add more machines or get a bigger one, right? So in this case, we have one customer hitting our machine. Uh, our machine is under zero, pretty much zero load. But if we have a cluster of 1,000 customers, then this is going to create burden on our hardware. And our solution is then to turn this monolithic pattern into a distributed pattern. So, in essence, distributed pattern is just the separation of responsibility. So, distributed systems separate responsibility to make system scalable. And what does it mean, scalable? Scalable means that we can easily add or subtract these hardware limitations, hardware to uh, serve forecasted traffic. Forecasted, well, I would say current and forecasted traffic, because sometimes we want to scale up before we reach the peak. So that's what a distributed systems is. Let's define it with a diagram. In the 3-tier architecture, we would essentially have 3 different components. So the first component, I'm going to draw a long rectangle, and then I'm going to draw a square. Then I will draw a circle here. This is our little distributed systems, and let's call this, what should we call this? Let's call this Amazon 2.0, right? This is distributed. Customer sends request to our request router, and this request router then forwards request to our compute, which then talks to the database tier, database layer, storage layer, whatever you want to call it. And the database layer returns the response back to the compute, and maybe compute returns it back to request router, and request router returns it back to the customer. So this is our flow. Now, what the difference here is that in our monolithic application, where everything sits on one server, and this one server has the responsibility of doing all 3, down here, all 3 components are separate components, and they can be scaled out individually. So for example, if we have 1,000,000 users, 10 to the power of 6, and let's say our traffic pattern is 100 to 1, so every 100 request is read, and 1 request is write. So we would, right, so we're getting a lot of heavy read requests. Then we would scale out this architecture differently. So for example, right, if we're only reading, right, so maybe we don't need as much compute, but we need more instances of the database to handle the read, right? So maybe we scale out 3 databases to handle 1,000,000 reads, right? Versus 3 databases to handle the read, versus if we have maybe 1 to 100, then perhaps we want to, instead of scaling out databases, we want to scale out the compute layer. So as you can see, if we divide up the responsibility into its own instance, then we can scale out these components individually.